This video provides instruction on how to solve quadratic equations in vertex form algebraically using the square root method. And so when we have in vertex form, we want to isolate the binomial square on one side of the equal sign, and then the number, the constant, on the other side of the equal sign. So we're going to solve this by, we want to move the 11 to the right side, so we're going to add the opposite. Subtract 11 from both sides. Subtraction property of equality. So now we have x minus 5 squared equals, what's that, 36? All right. Now, once we have the binomial square by itself, how do we undo squaring? That's right, we're going to take the square root. So we're going to take the square root of both sides. So we'll take the square root of x minus 5 squared. And here's a very important step here is you have to take the positive and the negative root when we take the square root of the 36. Okay, so when we're taking the square root, we have to take both the positive and the negative root, because we know negative 6 times negative 6 equals 36, and positive 6 times positive 6 equals 36. So when we take the square root of the x minus 5 squared, that just becomes x minus 5. We don't need the parentheses anymore. It's to the first degree. X minus 5 equals plus minus 6. So that plus minus means it could be negative 6 or positive 6. So we're going to write two equations. We're going to say x minus 5 equals negative 6. And then we're going to also say that x minus 5 equals positive 6. All right, now we solve those equations by adding 5 to both sides. So we're going to get x equals negative 1. Do it to the other one as well, x plus 5, and we're going to get x equals 11. So our solution set is, there's two answers. X can be negative 1, and x can be 11. All right, we can check that. We can check it. So we check it by substituting back into the original equation to make sure it gives us a true story. Thing is, we have to check twice now, right? Because we got to check both of them. So let's check x equals negative 1. So we're going to go negative 1 minus 5 squared plus 11 has to equal 47. So we get negative 6 squared plus 11 has to equal 47. So this is 36 plus 11 equals 47. Bingo. 47 equals 47. Check. Okay? Then we do the same thing with 11. I'm just going to do this one verbally. Okay? 11 minus 5 is 6. 6 squared is 36. 36 plus 11 is 47. So we get 47 equals 47 as well when we check x equals 11. You get the same thing. Okay? It's a test. You're going to want to write it out. Make sure you do it right. If you're just doing practice, a lot of times you can do these mental checks in your head. Here's another one. This time we have an a value, right? We have 7 in front of the parentheses. So let's take a look at how we simplify this one. So first thing, let's move that 5 to the other side. So we're going to add negative 5 to both sides or subtract 5 from both sides. So now we have 7 parentheses x minus 2 squared equals 35. Now here's the thing. Order of operations, we cannot do distributive property like you did in linear algebra, right? When you had x minus 2 to the first degree. You just distribute. Well, we can't do that because we have to do the exponents first. So you have to go x minus 2 times x minus 2 first. But we don't want to do that. What a mess. So how do we undo the multiplication? That's right. We're going to do division. So we're going to divide by 7, both sides. Divide by 7, because 7 over 7 becomes 1. So now we have x minus 2 squared equals 35 divided by 7 is 5. All right. Now we're going to square root both sides. So let's take the square root plus minus. Okay. So I get x minus 2 equals plus or minus the square root of 5. Okay, let's break it down into two equations now. So x minus 2 can equal the negative square root of 5. X minus 2 can equal the positive square root of 5. Now we add 2 to both sides, plus 2 plus 2. Be careful, you can't combine the number with the square root number. You got to keep them separate, right? So you get x equals 2 minus the square root of 5. Other one, same thing, plus 2 plus 2. We get x equals 2 plus the square root of 5. Those are the exact solutions. Absolutely exact solution. Now, if you want the approximate values, you'd have to figure out the square root of 5. So you take a calculator and go square root 5. Calculator tells you 2.236. I'm just going to say 2.24. 2.24. All right, so we're going to get x equals 2 minus 2.24 and x equals 2 plus 2.24. So we're going to get x equals about negative 2. Just negative 0.24, my bad. Negative 0.24. Okay, sorry. And then x equals 4.24. So, did I do that right? Negative 0.24 and 4.24 is correct. Now, if you do a check on these, you could use those approximate decimal solutions, and when you do it, it's not going to come out exactly 40 equals 40, but you'll get somewhere very, very close. Okay. If you want to see one more example, we'll do one more here. So we have subtract 10 here, so we're going to add the opposite here. So we're going to change it by plus 10 to both sides. Plus 10 plus 10. So then we have 8 parentheses x plus 9 squared equals 80. Now we are going to divide by 8. Divide by 8 both sides. So we get x plus 9 squared equals 10. Now we're going to take the square root of both sides. So we take the square root, plus minus. So we get x plus 9 equals plus or minus the square root of 10. Let's break into two equations. I'll do it up here. X plus 9 equals negative square root of 10. And x plus 9 equals positive square root of 10. Okay? So I'm going to subtract 9 from both sides. I get x equals negative 9 minus the square root of 10. And then minus 9, x equals negative 9 plus the square root of 10. Now, again, those are the exact answers. If I want the approximate solutions, right? Approximate. Well, square root of 10 is about 3.1. So negative 9 minus 3.1 would be about negative 12.1. And then negative 9 plus 3.1 looks like it'd be about negative 5.9. If I did that right in my head. Okay, again, we could check these. If you check the approximate decimal solution, it's not going to come out exactly 70 equals 70, but it should be very, very close. And actually, you could even check it and get the exact answer if you plug in negative 9 minus the square root of 10 and you simplify that process. I just don't want to go through and show you that whole process. It's a lot of work right now, and we don't need that for our class. All right, hope this was helpful. Thanks, and have a great day.